Let me share my screen.
They'll take over, right? Yes.
And now I have a very tiny video window. Oh, there we go. Now I can see you again.
Quick audio
Well,
check before we start, Alan. Can you all hear me okay?
Yeah.
Yeah?
Yeah.
All right.
all right.
Cool.
I assume you can hear me because you're reacting to me. So
Yes.
awesome. Well, hello, and thank you guys for having us. I'm just going to jump right into the talk. We are, well, I'll back up. My name is Alan Ridlehoover. As Rylan just said, I'm pretty passionate about Ruby. I work for Cisco Meraki. I lead platform engineering for Cisco Meraki. And Rylan, you stole my line. We are probably the largest Rails shop you've ever heard of. You've never heard of. We have, we'll get into that in a minute. Fito?
Yeah, I'll go ahead and introduce myself. Hi, my name is Fito von Zastrow, and I'm a staff software engineer at Cisco Meraki in one of Alan's teams, and I'm focused on modularizing our Rails monolith. So I'm super excited to talk about this. Before we get started and talk about that, though, we just wanted to really thank Boulder Ruby for inviting us, and would like to thank the organizers for indulging us in, letting us switch up things and give you a preview of a talk that we're planning to give at RailsConf in July. So if any of you are going to be there, you'll see a more polished version. So this is the first time we are going to give this in public. We hope you like it. This is also, I think, the first time we're going to present together, but not physically in the same place. So forgive any if we like step on each other or something like that. So we're not done tweaking this talk. We would love your feedback, and our contact information is at the end of the deck. Okay, so with that out of the way, Alan, you want to kick us off?
Sure, I can try. As you might be able to tell from my voice, I'm a little under the weather. So if I'm coughing, I might just hand this over to Fito while I pop cough drops and try and get my voice back. So we call this talk Derailing Our Application, but it's not about moving off Rails. We are not moving off Rails. Rather, we want to share how and why we're decoupling our business logic from Rails constructs like models, views, and controllers. So let's start with why in the world would you want to do that? Well, in the beginning, Rails 1.0 shipped in December of 2005. Work began on Meraki's monolith in April of 2006, and at that point, people were still writing fat controllers. No one knew about the Rails way. We hadn't yet lived through the Ruby 1.9 upgrade or the Rails 2.0 upgrade. There were no RESTful routes. You could not chain active record queries, and you had to do dependency management manually because Bundler did not exist. Plus, we weren't well-grounded, eloquent, or practical. But that didn't stop Cisco from acquiring Meraki in December of 2012 because they recognized that Meraki was innovating incredibly fast. And that's despite the fact that the central concepts in our application were written long before any of those best practices were established. Note, this is not an actual class diagram, but it's not far off. Now, at that point, there were fewer than 40 engineers. The app was about 3,400 files and close to 250,000 lines of Ruby code. 7 years later, when Fito and I joined, there were around 200 engineers, close to 9,500 files, and nearly 1,000,000 lines of Ruby code. But that growth hasn't slowed, as you can tell by the scale of this chart. Today, we have about 1,000 active contributors to the code base. There are nearly 60,000 files, and there's over 4 million lines of Ruby code. As you might imagine, with a code base this large, whose central concepts were laid down almost 20 years ago, before Rails best practices were a thing, there's some pretty complex stuff going on in there. You might even describe those areas as a bit of a mess, but According to Sandy Metz in her post entitled The Half-Life of Code, most applications are a mess. And having a big mess may actually be a sign of success. It's certainly a sign that your application has survived a constant barrage of new requirements added under urgent time pressure, which tends to drive applications toward disorder. And as entropy grows, velocity gradually slows. And that's the tragedy of many successful software applications. To become successful, we needed to add as much functionality as we could as quickly as possible. There was little to no time to pay down debt, and over time it became harder and harder to add new features. That sounds pretty bad, but let me tell you, it beats the tragedy of unsuccessful software. So we're happy to have this problem, and that's why we're derailing our application. But what does that mean? Fito, you want to tell him?
Yeah, I'm glad you asked that. So, in order to answer that question, though, I need to talk a little bit about software architecture just for a minute. Now, the way we think about it, software architecture is about how you organize your code or how we organize our code to promote the qualities that we desire, that we want to see in our software. Rails, for example, uses its architecture or the way it organizes code to promote rapid onboarding through convention over configuration. Everyone knows where the code goes. Or to promote separation of concerns by embracing MVC, right? You have your models, views and controllers. And to promote testing by including things like request specs that are there in the framework for you. Now, all of that worked really great for us up until about right here. Now, at some point between 250,000 lines of code and 1,000,000 lines of code, Rails' architecture alone was no longer enough. As the application grew, it gradually became harder to figure out where to make changes. And testing those changes became incredibly difficult. And both of those things also caused onboarding to slow down. Now, there was evidence of this when Alan and I joined. Onboarding was expected to take 9 months for somebody, so 9 months before you were productive. Code seemed to gravitate towards the central concepts of the app, even when it wasn't related. Code would just go there. And test coverage was below 50%, which that's a lot of code without any test coverage. But why? You might be wondering, well, because like Alan said, our application was under a constant barrage of new requirements that needed to be completed under urgent time pressure. And then somewhere around here, Cisco announced that the Meraki dashboard would become the cloud management platform for all Cisco devices. Now, that's huge. That meant that we were going to need to onboard hundreds of Cisco engineers. Very few of them knew any Rails or even Ruby, and they would need to know where to add their code and how to test it easily. So we really needed to speed up onboarding. We also needed it to be obvious where the code should go. And we needed to make testing less cumbersome. But how do you go about doing that in such a large code base? Alan, I'm going to hand it back to you.
Well, so we had identified these particular problems that we wanted to solve, and we started thinking about what attributes we could see in our code base that would help us instill those attributes. So like, how could we organize our code to instill those attributes? We came up with 4 different attributes that we wanted to instill. The first was clarity. In other words, we wanted it to be easy to read and easy to change our code. This clarity, we hoped, would help with onboarding. Second, we wanted to give teams autonomy to allow them to experiment in isolation, so they wouldn't need to gain consensus across the organization, and so that they wouldn't try to impose their solutions on others. Both problems we've run into in the past. Third, we wanted to promote accountability so that we knew which team to talk to when a file's test coverage sank or when a flaky test was discovered. And finally, we wanted our code to be more testable, because obviously well-tested code is easier to understand, it's easier to change, and it's obviously more reliable. So how do you instill specific qualities into our code base? In what ways could we reorganize our code to support these 4 qualities? Well, we chose 2 different approaches. The first is modularity. The second is boundaries. Modularity is about breaking large things into smaller things. And here it supports the clarity and testability attributes that we wanted to instill. And then boundaries are walls within a code base that enable the autonomy and accountability we're after. How does the phrase go? Fences make good neighbors. We were looking for the fences. And we also realized that boundaries are going to reduce the cognitive load across the entire engineering organization. You no longer need to know about all 4 million lines of code. Instead, you can focus only on the code that your team owns. So we figured out what problems we wanted to solve. We wanted to speed up onboarding. We wanted to make it obvious where code belongs. And we wanted to simplify testing. From there, we decided on the attributes that we'd need to instill in our code base. We chose clarity, autonomy, accountability, and testability. There's got to be an acronym in there somewhere. And finally, we chose a couple of different strategies to reorganize our code in support of these attributes. We chose modularity and boundaries. But will it blend? Fito, can you show us some examples?
Yes. All right, so we're going to take a look at how we chose to organize our code in our controllers, views, and models. Now, the code in these examples is made up. It was inspired, though, by real production code. So the shape of the code, the complexity you're going to see there is very real. That was not made up. Instead of networking concepts, we're going to be using concepts related to coffee machines.
That's kind of our thing.
Yeah, that's our thing. All right, so the first thing we decided to do was to remove business logics from controllers. We started there for a couple of reasons. First, our business logic is the most valuable code we have, and it's really what differentiates us from our competitors. It's also where developers spend most of their time adding features and fixing bugs. So it is where we get the biggest return on investment from having high test coverage. And second, controllers are, in some cases, can be really difficult to test. The more logic you have in there, the higher the difficulty. And so they often require complex setups in order to exercise every code path. Like I said, we do want to exercise every code path because this is the most valuable code we have. And so because testing controllers got so difficult, eventually people stopped writing tests, opting instead for manual testing, which feels faster. You're done with the code part, you're manually testing it, but it's actually slower. So we decided to restructure our code to make it easier to test via simpler, quicker unit tests that require less setup. Let me show you an example. Okay, so this is a controller that handles requests to update the settings of multiple coffee machines that belong to a cafe. Now, don't feel like you need to understand the code. Instead, I want you to focus on the shape of the code and the variety of colors on the screen. Both are good indicators that there are lots of different things going on in the controller, and that gives you a sense for the complexity here. Now, let me walk you through some of the high-level things that are going on. So up here, there is an active record transaction, which contains a loop. Now, this is looping over an array of arrays that contain a coffee maker ID and the corresponding changes to that machine's configuration. Now, inside the loop is where most of the business logic lives. The code is doing things like validating input, populating errors, serializing a hash of changes, and finally, it saves the settings. Now, back outside the loop, there's a little bit more business logic. The controller is creating a cafe event record, which is probably consumed by some notification system or some other part of the system. It's like tangentially related to the actual goal of updating settings here. And then finally, there's some aggressive exception handling. there's a lot of code here, like who knows what could happen, right? And so at the end there's an ensure block in charge of rendering the response. Now, again, there's a lot going on here, but we don't ask anyone to solve all these problems all at once. In fact, our approach is to focus on the body of the loop first. And I have to say this, before we go there, it is important to ensure that you have at least some high-level tests covering this. We just want something that provides just enough coverage to tell us if we completely break the code here. So let's assume we have those tests and get started with the extraction. All right, here we extracted a class called update water tank settings. This class, that's on the right, encapsulates the procedure that was inside the loop. And it's now only concerned with a single coffee maker. This makes testing the logic much easier since you no longer have to think about HTTP requests. You don't have to think about a user logging into the system, and you don't have to think about HTTP responses. You also don't have to think about the loop. You can focus on the effects this class has on the settings of a single coffee machine. This is a very simple thing that we did here, but it makes testing so much easier. And as a bonus, turns out this procedure was primarily concerned with settings related to a coffee machine's water tank. So extracting this class gave us an opportunity to give it a more descriptive name, which makes it easier for new folks to then find this code. But there's still a lot of logic left in the controller. You can see that on the left-hand side here. So the next step is to extract that remaining business logic out into another class. So here we have created a new class called update coffee machine settings, and we've moved the rest of the business logic there. Now, if you look at the controller on the left here, it looks a whole lot more like a scaffolded controller. It's only responsible for handling HTTP requests and sending back a response. Now, it collaborates, though, with the new class to build that response. This new class, on the other hand, still has several responsibilities, way more than we would like. But we're going to defer that work for the next person to touch this file because our goal here was to make it easier to test our business logic. And now that it's out of the controller, we've accomplished that goal. Okay, so extracting that business logic out of the controller helped with clarity and testability. But in order to promote autonomy and accountability, which are the other two attributes we wanted to promote, we need boundaries. We started this with having all the code in the controller's directory. Everything was in the controller. But now that we have extracted classes, we have the ability to move that code into a different directory. So here we introduced a domain directory under app, and then it has a subdirectory called coffee machine. And we went ahead and moved those new classes in there. Now, this directory structure provides a namespace where we could put all the business logic related to coffee machines. And it makes finding the code related to coffee machines much easier, which speeds up onboarding. It also allowed the team in charge of the coffee machine features to take ownership and experiment with different approaches without requiring consensus from the entire organization, but also to be accountable for the level of test coverage in this directory, or if there's any flaky tests coming out of here. Now, another benefit of this structure is that it allows us to use the namespace to convey some of the information that would otherwise be just communicated via the class name. So for example, we were able here to rename update coffee machine settings to just update settings since the namespace already implies that this is about coffee machines. All right. That was what we're doing with controllers. Alan, do you want to share what we tackle next?
Sure. So I hope this is obvious to people, but you shouldn't put business logic in your views. We do have some in our views, though. And so the next step we took was to focus on removing it from our views, specifically ERB files. Now, views present a different challenge. ERB files cannot be processed by community standard code quality tools like Flog or SimpleCov, so you have less visibility into what's going on in there. View tests are actually quite difficult to write and can produce false positives due to the fact that you have to set the instance variables that the controller would ordinarily provide to the view. And then once you do that, it's possible to change the controller without breaking the test. Plus, the embedded Ruby syntax is much harder to read than just plain old Ruby. So we've restructured our views to make the code easier to test and easier to understand. And as a bonus, we can also now measure the quality of the code. So let's take a look at an example. So here on the left side, we have a controller in charge of rendering configuration properties for a coffee machine. The controller itself is not doing much. It's just finding the coffee machine, setting a few instance variables, and rendering a template. On the right-hand side, we have the view, or the ERB template. Now, this template contains the business logic that decides which properties get rendered under what conditions. The output is a text file with key value pairs separated by new line characters. It looks like this. It's just a plain text response with a list of properties, each property on its own line. Each line consists of a property key followed by a colon, followed by a single space, followed by the property value, which may contain spaces. Now, looking at this response, we determined that we don't really need ERB for this. Excuse me. A plain old Ruby object, or PORO, should be all we need, basically a serializer. Again, we recommend making sure that there's at least a high-level test before extracting this code. And so, for the sake of time, we're going to assume we have that. And let's just go ahead and extract the code. So here's the controller and the ERB template as we left them a moment ago. Let's replace that view with a PORO. So here we've created a new class called Coffee Machine Configuration. This class encapsulates the business logic in charge of building that configuration properties. We've also pulled the code that calculated the instance variables in the controller into the new class. The reason for that is the variables were deeply embedded in the view's logic. The controller had no use for those variables other than setting them so that the view could access them. However, we left the code to find the coffee machine back out in the controller because the controller does use that logic to determine what the correct HTTP response should be. The new class, on the other hand, does not even need to be instantiated if there's no coffee machine found. Now, the benefits of this extraction are the coffee machine configuration is much easier to test than the ERB view. We can get coverage and complexity information for the new class, which is great. And the controller is also much easier to test since it's only responsible for the HTTP request and response. There's no more business logic in there. All right, so let's look at where this code ended up. We started with the code in the controllers and views. Then we replaced the view completely. The view does not exist anymore with a pure Ruby object. Now, we were calling that class Coffee Machine Configuration, but we already have a domain Coffee Machine folder, so we can just rename it to just configuration and put it in that namespace. All right, Fito, what's next?
Well, next we remove business logic from our models. And I want to acknowledge that this might seem unnecessary or counterintuitive for some folks. I have definitely heard that, working with many engineers, particularly given that the skinny controllers and fat models is considered a best practice in the Rails community. However, we have a few reasons to move our business logic out of our models. Now, again, our code base is pretty old, so most of our models represent those core concepts in our application, and that made them magnets for code. So the more code gets added to these models, the lower the cohesion and the higher the chance that the methods will be implicitly coupled with each other. So what we've observed over almost 20 years in this code base is that models tend to become junk drawers. And it makes it hard to draw boundaries or take ownership of pieces of this model. Plus, putting business logic in something like act to record lifecycle hooks and scopes really makes the code a lot more difficult to test without involving the database. So once again, we decided we wanted to restructure our code to make it easier to test and possible to draw boundaries. So let's take a look at that. All right, on the left, we have a controller action that's in charge of broadcast or returning broadcasting details about a coffee machine. The controller queries the database to find the correct coffee machine and then calls the broadcast details method on the coffee machine model. Now, on the right, we have the model. The broadcast details method checks various attributes on the model and builds a string that contains the machine name, recent activity, and the supply status. Now, like we've said before, we recommend making sure you have at least a high-level test before extracting this code. And assuming you have that, we can get started. So here we extracted the logic from the broadcast details method into a new class called coffee machine broadcast details. Now, the class receives a coffee machine and performs the same logic to build a string that contains the machine name, the recent activity, and the supply status. But this new class has a few advantages. First, it is no longer implicitly coupled to the model's attributes. This makes it more extensible. As long as it receives an object that responds to those same methods, you can use it in other contexts. Second, it's easier to test since the coffee machine object that you pass in the initializer can be more easily stopped in unit tests for this class. And finally, the code in the class is no longer accessible to other methods in the model. Or if you had module mixins in there, none of that can access this code anymore. And that prevents that incidental coupling via referencing other methods or instance variables in your model. Plus, we now have the ability to move this code inside a boundary. We started with the code in a controller and really most of it in the model. We then extracted a class out of the model, and that means that we can now put the new coffee machine broadcast details class in the domain / coffee machine directory. And we can rename it to just broadcast details. All right, so that was a brief look at some examples of how we've approached extracting code out of these Rails constructs. If I were to summarize the approach, we are putting our business logic in plain old Ruby objects. And we're moving these objects into namespaces to create these boundaries around domain concepts. Now, if we bring together all the classes we just extracted in these examples, the directory structure looks like this. You may have noticed that these classes are not organized by pattern or framework concept. If we think about the examples, update settings and update water tank settings could be considered service objects, while broadcast details and configuration are more like serializers. We have explicitly decided not to be prescriptive about how the code should be organized inside these domain directories. And this has allowed teams to decide what works best for them. Sometimes they organize the code by subdomains, like the team owning coffee machine might decide, oh, let's make a water tank subdirectory and put the update settings for water tank settings there. Other teams have decided that they want to organize it by pattern and they will create services and serializers. And what's been fascinating to observe is that some teams initially adopt one organization style, but then later, as they had more code and their team grew, they chose to reorganize it and go with a different style. And that's great. They had the autonomy to reorganize their code without requiring the whole organization to come along with them or agree with them. So we're just about done here. Alan, you want to close us out?
Sure. So let's review, and then I'm going to close on a completely orthogonal thought. So we set out on this adventure because we needed to speed up onboarding. We wanted to make it obvious where code belongs and to simplify testing. We chose those 4 attributes to instill in our code: clarity, autonomy, accountability, and testability. And finally, we chose to modularize our code and add boundaries as a means of restructuring our code to support those qualities. Now for the orthogonal thought. Who here has heard of 3x? Raise your hand if you've heard of 3x. Not many of you. 3x is Kent Beck's smashing together of 2 completely separate ideas. And if you'll indulge us for a second, we'd like to share these ideas with you. You should definitely go watch this talk Kent gave back at Pivotal back in 2019. Not right now. You can watch it later. The first idea is the idea of planned versus iterative development. Obviously, Kent Beck is the extreme programming guy. His whole career is wrapped up in Agile. Basically, what he's referring to here is planned development, which is what we traditionally call waterfall, versus iterative development, which is what we generally refer to as Agile. The second idea comes from economics. It's about concave versus convex curves. And I'm going to need a few slides to explain this concept. A concave curve is one that requires very little upfront investment and usually results in small losses, but occasionally it pays off really big. This is venture capital. A convex curve, on the other hand, is one that requires a large upfront investment and usually results in a small profit, but a consistent profit, but can occasionally result in very, very big losses. This is banking. And in fact, I'm going to steal one of Kent Beck's lines here. I don't know if you know this, but this is a fact. The 5 worst days in the banking industry wiped out all banking profits for the last 500 years. That's how big a negative downside this is. So, who can guess which methodologies are best suited for which one of these things? Well, of course, the concave curve favors rapid exploration of many small ideas. That's a perfect environment for iterative agile development. And convex curves favor the reduction of risk because the downside is so big. So they're perfect for planned development. Now, who could guess which technologies are best suited to which of these curves? Well, we're here to Ruby meetup, so obviously Rails is the obvious choice for the concave curve. The velocity with which you can ship ideas is phenomenal, allowing you to try a lot of new things and iterate. It's part of the reason Meraki was so successful early in our life. And Java is the more traditional choice for plan-driven, risk-averse projects on the convex curve. Or today it might be Scala or .NET if you're a Microsoft shop. All right, so everyone get concave and convex? All right. It actually turns out that these are not 2 curves. They're 1 curve. And as Kent sees it, there's 3 different phases of development along the curve. The first phase is called exploration. Here's the concave portion of the curve. So you're running lots of cheap little experiments, searching for the one big idea that'll pay off. And when you find it, you enter expansion. And this phase of development begins once you find that thing and it starts taking off. Everything in this phase is about keeping up with scaling demand. This is the point at which Twitter bailed on Rails. They hit this point and could not make it work. And then finally, once you begin to get a grip on scaling demand, you enter the extraction phase of development. Once you're fully into the convex portion of the curve, risk aversion kicks in, and the goal here is to extract value from that system that you already have. Okay, got it? Everybody got it? Awesome. So Rails architecture and conventions are really well suited for high velocity iterative development. And at a small enough scale, you can ride Rails through all 3 phases of the development. I think Basecamp is a perfect example of that. But for larger code bases, the Rails architecture falls short. On the other hand, code bases on the convex side of the curve are often built in Java or Scala or .NET. These languages don't offer the same velocity as Rails, but they do offer architectural guidance for large-scale code bases. Concepts like design patterns, domain-driven design, and TDD all came from this community. Patterns of enterprise application architecture in particular stands out, and ironically, it documents the design pattern known as active record. So Rails is not incompatible with these patterns, but because it's like the community is so focused on startups and being the one-person framework, small environments, small apps, they just haven't adopted or accepted these patterns, these enterprise scale patterns. But it is totally possible to embrace these architectural patterns with Ruby and Rails, and that's what we're trying to do. So with that, we would love your feedback. We have a whole bunch of ways to get a hold of us here. Take a picture. Yeah, that's the best way. Or watch the recording later. And with that, I'll leave that slide on there and say thanks. We have time for questions, I assume.
Yes.
I have a question. It's Joel from GitHub. Good to see you guys. The question I have is I noticed that your domain objects, your domain folder, its subfolders seem to map one-to-one to models. So like you have your domain folders are like coffee machine was also an active record model, I assume. So I'm curious about does that mean that sorry, let me say this a different way. Did you consider having subfolders within your models directory to keep that mapping aligned versus coincidental? So whenever I see two things that are named the same but exist in two different places, I see that as a potential source of confusion or other issues.
Yeah, that's a great question. I think that's an artifact of the sample here. Internally, we have, I don't know, a dozen product lines, and each one of those product lines is one of the top level folders. There are not models that differentiate those product lines. So for example, a device is a, well,
it's kind
we
of
don't
a
call it
shared
device.
concept.
Yeah, it's kind of a shared concept across all the
Yeah.
product lines. And so that's the model that represents all the different kinds of devices. Whereas here in this simple example, you're right. You're absolutely right. The coffee machine class is both a model and a namespace in that domain folder. That's actually great feedback that we should probably address before we get to RailsConf.
Yeah, I think I'd love to see an example of that because we are seeing similar things in our Rails code base, and I think it might make that example land a little better.
Mm-hmm.
Thank you.
Mm-hmm.
Hey, Lawson from Shopify. Can you? I'm curious if you could talk about your process of defining boundaries. It's like an extraordinarily challenging thing to do when you have a large code base that's fairly interconnected. And then like a follow-up to that is, can you talk about how you're thinking about enforcing the boundaries to prevent the spaghetti from reforming like across your domain directories?
Yeah, I think I'm gonna surprise you with the answers. The first one is nobody sat down and designed the thing up front. What my team is the Ruby modularization or modularization in general. We're doing something similar in JavaScript as well, but we focus in Ruby. And our focus is not to do the modularization, is to teach people how to go about extracting classes. We've been doing this now for a few years, and we have organically arrived at an organization of code that makes sense for the teams that own that code. So we did not pre-design, okay, you guys are, these are the directories, go move your code. Teams will pull out their code, and then there's been a little bit of reorganization that's happened, but for the most part, people already knew where to put their code. They didn't know where to put somebody else's code, but that's fine. They don't usually, touch that code. And for the second part, we have been waiting to like delaying for as long as possible to introduce any kind of enforcement of boundaries. And we have not yet run into that issue. You know, the problem of like, oh, you know, there are now references to private classes in other namespaces and people are stepping on each other. That has actually not happened. Um, except for maybe a couple of cases where the concepts were actually shared and they shouldn't have been taken over, but I can probably count them with one of my hands comfortably. So we at some point had the idea of, okay, let's introduce something like backwork. And honestly, we haven't needed it.
And
So far.
Eileen's talk at Rails World last year pretty much was like, maybe we don't want to do that.
Yeah. So our approach is that rather than enforce these boundaries and enforce modularity, we want people, it's a tool. We want people to understand why we're doing it and embrace it as part of their development practices. And, you know, to be a tool in their toolbox when they are working on very complex controllers or models. Like don't go through the pain of trying to test that. Obviously it's hard. Extract it first and then test it. And that was kind of like the carrot we gave folks to do this extraction work.
That, and we can give you like code quality data that you couldn't get before on things like
Right.
the
So
views.
about I hope I can share these stats on, but about half of our Rails code base is now in these owned namespaces. And most of the development is happening there, and that the code in those own spaces has over 97% test coverage, and it keeps going up incrementally.
Yeah,
And
when we started this process, like we said in the talk, actually before we started this process, it was around, I don't know, 48% or something.
yeah,
And because of ownership, people taking ownership and taking accountability for the code that might page them at 3 a.m., all of a sudden we've seen that code ownership result in massively increased test coverage numbers.
one of my happiest moments after we had been doing this for a couple of years, and then at some point I saw the first own directory that like organically hit 100% test coverage without anybody like nagging at these teams, and I was so happy. So I went and interviewed this one of the tech leads in that team, and I was like, without like preceding an answer, I just asked them, tell me more about why you guys did that. Like, what value are you getting out of this? And their answer was basically, we needed to move really fast on this, and you know, we really needed to make sure that it was working by a particular date, and so these tests were helping us move super fast and prevent regressions. And I was like, all right.
Yeah. I find it interesting. Oh, I see another question. I was going to say, I find it interesting that GitHub and Shopify were the first two. Joel, are you still at GitHub? Oh, you are. Okay, so GitHub and Shopify. Who else can we, what else can we answer?
Hi, my name is Ben. Until 2 months ago, I was at Square, and I worked over there for 6 years. And I had the opportunity to work on a relatively large Ruby code base. I mean, not as large as yours, like maybe 7,000 files. And actually, I worked pretty much on the exact same problem on how do we go to chaos to something that is more or less organized. And one of the challenges that I faced was actually motivating teams and empower teams to reorganize their code through domain. Because just moving one single file in our code base basically will result in thousands of failures in aspect or unit tests. So how do you scale the operation? How do you empower teams to actually reorganize their code base when you have, I don't know how many hundreds of thousands of files. I don't remember what was the number, but that seems like pretty huge.
We're about 60,000 files. Let me make sure I understand the question. So it sounds like you were having tests break because of the location of files. Is that correct?
Just the process of moving files, just itself was very challenging. So team would basically be very reluctant to do that, to reorganize their code base by domain.
We are not asking people to move files necessarily. We are asking people to extract code out of existing files into rows that are brand new, that can live wherever they need to live within that domain structure. I think the difference there is that like you're not trying to figure out, like Joel suggested, the directory structure under the models. So, Fito, do you have a more specific answer? You're muted.
Thank you. So regarding the difficulty of the task, it can be difficult sometimes. We host office hours pretty much every day, and that's actually where my team spends a lot of our time. So people can just drop in, and we promise people that we can get it done in 10 minutes. So we try to hold ourselves accountable to that. And one way to like keep it under that amount of time is take smaller chunks and only change things that you have a reason to be changing. So you're going to fix a bug, you're going to add a feature. The first thing you should do is ask yourself, should I be extracting this? And that's a commit, and you ship it, and then the next changes are much easier. And so, like we mentioned earlier, we have a ton of developers working on this code base that might not have previous Ruby and Rails experience. So for them, writing an RSpec test can be very difficult, let alone understanding the output of a failing test. And then in terms of like the challenges with moving files, it hasn't been a huge issue, probably because of what Alan was saying. We're going from like tons of code in fewer places to smaller objects rather than just, multiple little objects that need to be rearranged. I hope that answers.
Yeah, thanks.
Can you guys? Hi, it's Sean here. Sean Collins. I was wondering about your team structure in these domains that you've extracted. Is it the case that each team has one domain, each team has a couple domains? Have you had issues where two teams like have to share a domain, or like, I don't know if you just like share?
Yeah, we have. So if you think about our product lines, we have wireless access points, we have switches, we have security appliances, we have IoT devices, cameras. Each one of those high-level domains is a domain folder. And then within that, those teams get to define what the internal structure of that folder looks like. And what we've seen is, keep me honest here, Fito, what we've seen is things like radio frequency settings might be a subdomain of the wireless access points. Now, it turns out that some of our security appliances also have wireless access points built into them. And so somebody has to take ownership of that radio frequency setting code. That particular feature it belongs to the access point team, not to the security appliance team, because they are the experts in radio frequencies. And so it had more to do with like who's the expert in this area than it had to do with which product line actually is relevant here, because they're both relevant. And if the security appliance folks need to talk to or need to write code in that radio frequency area, they're welcome to do it. They just need to get a code review from the folks who own it.
Yeah, I guess there is a little bit of enforcement thinking about that question before, not in terms of like what can you access through the boundary, but we do want teams to talk to each other. So if you're going to make a change in somebody else's code, that is enforced via CI. You have to get a check mark from somebody in that team. And so, yeah, like the security appliance folks are welcome to open PRs against the code in the radio frequency area, but somebody in the frequency I'm forgetting the name of the team now. Somebody in that team, access point team, needs to be aware of it, because if coverage goes down or if there's a bug in production, they're probably going to get paged for it. So they need to understand what's happening. And that's actually worked pretty well. And there's a lot less share code than people imagine, actually. One of the challenges we found before we started this process was that, and actually thinking back at experiences at other companies, I think it's pretty common, particularly with Ruby. Folks will come up with some solution for a problem they have at hand and be super excited about it and generalize it for everyone to use it. Because, everyone's going to want to use this thing. It's so cool, solves everyone's problem. And then turns out nobody really wanted it. And so
a framework with one user.
Yeah. And so this is one thing that we are kind of encouraging within your team. So if you can convince your team to use it, great. And if you're having a lot of success or you're excited about it, you can go talk to other teams about it. We have forums where folks can demo what they're doing. But you kind of have to shop it around before making it a framework in the Rails app for everyone. And now everyone needs to kind of like wade through it or decide to like work around it.
Yeah, I don't know about the other, I don't know about the rest of you here, but some of the challenges that we run into are things like there's somebody who'll join the company and they come from a background in Rust or some other language, and all of a sudden they're bringing those concepts into a Ruby app, a Rails app. And while that's okay in isolation for those, like, I'll just pick the Rust, like the command pattern in Rust. We don't really want that everywhere in our app. But if one team decides, hey, that's useful for us, more power to them. Like, and if eventually, if they come in front of the rest of the team and they demonstrate what they're doing and it's that effective, then maybe we will adopt that more broadly across the organization. But it's not done by putting something into the shared space and saying, hey, everybody go use this. It's done by holding it into your private space, getting it working for you to where your whole team is using it effectively, and then like selling it to the rest of the company, like telling them, hey, look at this cool thing. This is what it's doing for us. If you want to try it, come check it out. And only then would we consider moving it out of that one domain and into more of a shared space. But we even might not move it though, like the radio frequency stuff, that still belongs to the wireless team. Like if you built the framework, it might still stay with your team. You guys are awesome, by the way. These are great questions.
Yeah.
We really appreciate the feedback. And Marty, you got one?
I do. I was curious because you had these 3 objectives that you set out for. How did you measure sort of progress along those objectives? And is that something you'd share in the presentation?
That's a great question. So onboarding still takes a very long time, especially if you're coming into the organization without any Ruby and Rails knowledge. And so one of the things that we want to do there is like minimize the number of things you have to pick up immediately. So there's like the idea of what is Rails and how do I use MVC? That's part of it, but also just by focusing them on only the code that their team owns, just cuts down the cognitive load of trying to onboard. So from like, how do we measure how long it takes somebody to onboard? I don't know that we've made a ton of progress on that, even though we've been at this for a couple of years. It still takes a long time. And because Cisco has invested in Meraki as the platform, for example, our switch team is currently onboarding all of the Cisco switch product lines into the Meraki dashboard. That's like 200 different SKUs. And they're having to so they're basically in the expand phase right now. Like that team is crushed with the scale of the thing they're being asked to do.
I'm
So
going to interrupt you for a second. One thing that I would add is that we ran, so before we started with any of this work, we didn't just, decide, okay, this is the most important thing right now. We do, I think it's every 6 months, developer surveys. And one of the highest or most voted, I guess, pain points was that, let me take a step back. We were asking folks, what's hindering your productivity? Like what would make you move faster? And because that's one of the things that you kind of lose when you join a large company with a large code base. You might find that processes are too convoluted. You might find that the code is too complex. So the number one thing that folks were mentioning was, it's difficult to find where to make my change, or it's hard to know where to go to, debug something or make a change. So navigating the code base was the most difficult thing at that point. And that is no longer the top
that's correct.
problem. Now you could look at that both like in one or two ways. One is we made it better. The other one is maybe there's something else now that's just more painful. But I like to think that we made it easier for folks to find their code, and so that particular thing hasn't come up as much. Now, in terms of so that's one thing, right? The reducing adoption or the time to get onboarded. Sorry. The other two characteristics, the testing is easy to measure, right? Test coverage just went up by a lot for the Rails app as a whole, but specifically for the code that folks had now moved into their own directories. So 97%. This is probably, that section of our code base is probably some of the best tested code that I have worked on in terms of our Rails app. And in terms of ownership, you could also tell that the fact that the difference in test coverage is there between shared areas and own areas as a kind of an indicator that people are taking ownership and caring about their code and spending more time testing it. And so there's a few ways we can tell that, oh yeah, teams are owning this and doing things like on their own, making the decision that they need 100% test coverage so they can move faster. And also what I mentioned about reorganizing their directories, because they now, their code has grown by 2x, and they think it's going to be easier to find it if they organize it differently. So they autonomously make that decision to change it. Those are kind of signs that they are owning that section of the code base. Whereas before, when everything is in controllers, models, and views, and maybe helpers and mixins, just the barrier to make significant changes is pretty hard, right? You're affecting everyone's work.
Any guesses as to what the number one pain point is now?
CI, sorry.
CI.
Yeah.
We have 180,000 RSpec tests. Even if only like 0.1% of them are flaky, it gets really hard to get something out the door. So we've invested huge amounts of money, not money, but like time and energy into how do we build a system that is resilient and doesn't like bomb the minute you run into a flake. That's the subject for another talk. It's actually really cool. Hello.
Hi, I'm Prashant, and we have similar story. We have 13 years of legacy code that we're maintaining, and we introduced some of the design patterns like MVP and MVVM patterns. So I was wondering, in your example with coffee machine, under the subfolder, there are some classes that are business logic, that have business logic, and some classes that are view-specific view concerns. So would you consider like renaming those classes as with the suffix of something service.rb for business logic, it's a service object, versus a view one would be a view model, suffix view model.rb, so that you can differentiate which ones are the view plain old Ruby objects versus which ones are the business logic objects.
Yeah, some teams do that with namespacing inside their domain folder. Like we mentioned, other teams organize things more by subdomain rather than by type of object. The main point we were trying to get to here in this talk wasn't necessarily that this is the end point. This is the, how do we get to where we can test this stuff? How do we get to where we can make onboarding a little easier? How do we get to where it's more obvious where things go? And I do think that, excuse me, knowledge of those patterns and like referencing pattern names sometimes actually can help. It can also intimidate and confuse folks who aren't familiar with those patterns. I don't know if you've run into that, junior developers who, I don't know what an MVC is. I don't know what an MVP is. What's the difference? Why do I need to know? So we haven't actually done anything to like enforce any of that. It's really up to the teams themselves, what the internal directory structure looks like inside and what the class names are and so forth.
Yeah, and I wanted to add, it's also about where the teams themselves are in that journey. Some teams are actually far enough along that they have added kind of a simplified interface around their section of the code base. So they are closer to what we would get if we were to use Packwork. But there's maybe a couple of teams that are there, and they have their code organized by I think of it by the patterns that they're following. For example, they have a services directory, and they have action classes that encapsulate a controller action. They have serializers, and they got far enough that, and this is not our end goal. We like our monolith. There's a lot of benefits of, staying in a monolith, but there are some parts of the system that make sense as a service with its own database. And by, first extracting their code into their own domain directory and then later building an interface that the rest of the code base uses to communicate with them, they were able to then take their data out, build a service, and then basically use that interface as a facade and completely move their service out. In this particular case, they needed to scale it differently, and it needed to be, if there was some data availability across different zones that needed to happen. And that's just to further illustrate that, this gives them the ability to try these things out without everyone having to be moving in that same direction. I hope we answered your question. Is that?
Yeah.
Cool.
Way in the back.
Way in the back.
So my name is Andrew. I feel like I'm very smarter. I'd see how you were dealing with this. But from my experience, I worked in a particular code base where there are all kinds of helpers and concerns, and it felt like everything was in 10 different files. And every time you had a bug, you had to just crawl through all this stuff, and it was a huge mess. And as I was listening to talk, I was like, yes, everything you're saying makes a lot of sense, but I was also getting these flashbacks. So I'm like, I just wish I had a nice big long method so I could walk through it and understand what it was doing without having to look in 10 different places. And I'm wondering if there's a way that you're organizing how you set up your file system as to like where you group things together, or something that helps alleviate that frustration of having to look in 10 different places, or some approach you have to deal with that issue.
I have a controversial answer. Don't use helpers. Don't use concerns.
That's not controversial.
So,
That's a huge problem, right? We have it as well. Like there are, I think, Fito, you did a talk internally one time about module mix-ins and how dangerous they were. And we pulled like some data on some classes, and there was, I forget whether it was a controller or a model, but it had like 70 different modules mixed into it. And I'm like, what the? At that point, like there's no like encapsulation left in that class. It's completely destroyed. It's like a sieve. Everything just falls straight through it. So it's hard. Well, you get into one of those methods that is just a sec, Joel. You get into one of those methods that is, you know, leveraging a module, or maybe it's using a variable that was set in a module, like an instance variable that was set in a module, and like you don't know where it came from. Like you've got 70 modules to look through to find it. Like it's definitely difficult. I'm going to pass to Fito first and then Joel, because I think Fito, you've got a look on your face like you have something to say there.
Yeah, no, I don't know. I have so many stories to tell about like module mixins. We highly discourage them. That's one of the reasons. They create implicit coupling between things that have nothing to do with each other. For example, like various controllers would include a mixin, and then that mixin happens to include another one, and then all of a sudden there's a, like Alan said, an instance variable in there that some other controller set that's not part of your inheritance chain. It's not part, like it's not related to you, but it's there in some big conditional. So there's some like horror stories there. We recommend folks to mostly extract classes. In some cases, some people are opting for, I guess, essentially functions like module methods. And that's not my preferred style, but that's okay. Mixins though are highly discouraged. And then in terms of having like, you can still get in trouble with classes that call other classes that call other classes, right? So we also recommend that you keep your inheritance chains pretty flat. We recommend you go with composition and hold off on creating inheritance chains until you have many different examples. So we try to just keep it simple, just a plain Ruby object. The majority of the code you'll see is like a controller calls a class, and that's it. And then that class will collaborate maybe with some models and maybe with one other class, but the majority of the business logic will be there. And that's usually good enough. Like you can test it well. We don't have to overcomplicate it and be like,
It's
yeah, you don't have to like take every concept and put it into a class and find the pattern that matches this. At the end of the day, our goal is to make the code easier to test, easier to find, and easier to, you know, debug when you have, if you have to.
Joel.
All I was going to say is it seems like what you're arguing for is kind of the opposite of the question, which is that when you break things up, you should be breaking it into pieces that you don't require any other context to understand. Like that almost seems like the primary criteria for these themes you're putting in, like the fence that you're building, is that you shouldn't have to have context.
Right.
So that is kind of like another way of saying your helper's comment. Like we shouldn't be splitting up things that we have. We should be isolating pieces of what we have. And there's a big difference between that.
Yeah.
Yeah, that's well put.
Yeah. One
You looking for work?
I wanted to add something there. One challenge with that though is if so in most cases when you're starting with like a controller that's specific to this feature set that you're working with, then you might end up just extracting the body of an action, a controller action. But in some cases you're going to have very tangled, gnarly, gigantic methods, and finding that class devoid of context that's easy to extract can be challenging. And so you might have to like just do some things that you wouldn't like if you were designing the thing from scratch, and extract things that are kind of wonky at first, but that allow you to add tests to the code. And then once you have tests, then you can more freely and safely then reorganize the code to into pieces that are well isolated from each other that you don't have to jump through.
And as a side note, I think doing have an extension can help.
That's actually one of the reasons I built the extension, was to show an inline version of the code.
Okay, I didn't catch the name of the extension earlier.
Code Beacon.
Code Beacon?
Beacon. Okay.
All right, I'll check it out. Well, I don't know what your time frame is like, but I see it's getting dark there. It's not yet dark here. I've got plenty of time. I'm happy to stay on if you guys are interested and have more questions, but I don't know if you guys are approaching the witching hour, I wouldn't want to hold you from going home and getting food or whatever.
Alan, we've been amused by your dog and, and window chasing.
There's a fly flying around my office, and the dog is trying to catch it.
Nice.
Yeah.
Any other questions, or you want to stay on and chat more? Pretty well covered.
Right on.
Another-
Well, if you got a picture, thank you. If you got a picture of the communication slide, feel free to drop us a note. Whether you have praise or horrible criticism, we would love to hear it. Because our goal is to make this the best talk we can for RailsConf. So thanks again.
Yeah, thank you.
Thank you. Cool.
Thanks, guys. Yeah, everyone, have a good night. Yep. Good afternoon and whatever you're doing. Take care, y'all.
Hopefully I'll see some of you at Rocky Mountain Ruby.
Yeah.
Sean, are you just like you're saying I told you so the entire time?
Well, no, I mean, like,